Welcome. This is the first of two screencasts on how to plot a function of two variables in MATLAB. In this screencast, we'll discuss the idea behind plotting two variable functions in MATLAB, and then discuss a couple of simple plots that we'll generate using the MATLAB commands we'll learn. The sequel to this screencast will talk a lot more about the things you can do with a function of two variables once you've plotted it. Now, plotting a function of two variables is quite a bit different than plotting a function of one variable in MATLAB, so it's helpful to go back to basics and think about how you would plot a two-variable function by hand. For example, let's think about the function z equals x squared plus y squared. Now, if I were going to plot this function by hand, I'd have to do it with points. Unlike a function of one variable, I can't just create a list of x values and then plug them into the function. I have to create a list of x values, then a list of y values, and then plug each combination of x and y values into the function. So how do we do that in MATLAB? Well, before we get to how we do it in MATLAB, how would I do it by hand? Well, if I wanted to create a list of x and y values, let's suppose I let x go from -3 to 3 with a step size of 1. So we're looking at x equals -3, -2, and -1, and so on up to 3. And let's let y be the exact same range of values, -3 to 3 with step size of 1. Now, that's 7 points each for x and y, and so it would create a grid of points that would look like this, with 49 possible input values for x and y. To generate something like the plot of the function z equals x squared plus y squared, I'd have to go through each of these 49 points and plug them into the function. For example, right here at x equals 2 and y equals 3, the output of the function would be 2 squared plus 3 squared, which is 13. And I would have to go through and do that for every single pair of x and y values that you see here. And I would interpret the z values as heights. So I would have a three-dimensional function where the xy plane represents the inputs and the height value gives me the outputs. Now, if this is my grid of points, then this is what the cloud of floating dots would look like. You can see each of those points corresponds to something in 3 dimensions. And if we spin this around, we can get a sense of the perspective and the depth that we have with any plot of a function of two variables. And if I then take those points and connect them with dots, like we did with our y equals x squared graph, we get something that looks like this, something that looks sort of like a hammock, or what we might want to call a mesh. Now, this is what we get when we plot just a few points, this 49 points. If the grid weren't 7 by 7, but rather 100,000 by 100,000, the grid would be very dense, and the resulting mesh that we see here would look a lot more like a solid surface, which is what the graph of x squared plus y squared really is. Now, all of that Calc 3 review is necessary because that's exactly how MATLAB goes about plotting two variable functions. We first of all have to create a grid of x, y points, and we do that using a special command. Then we're going to apply the function we have in mind to the grid to get z values. And then finally, we're going to plot the resulting mesh. And in part 2 of this screencast, we're going to learn how to adjust the look and feel of the plot once it's been created, just like you use the plot tools window or some plot options to adjust the look and feel of a one-variable plot. So now let's go to MATLAB and see how this all works. So here we are in MATLAB, and let's use MATLAB to plot the function z equals x squared plus y squared, just as we saw earlier and we did by hand. First thing we have to do, as we know, is to define a grid of input values. We have a special command for that in MATLAB, and it goes like this. First of all, this command has two outputs, x and y, my variables I'm going to enclose in square brackets. On the right, I'll talk about that output in just a second. On the right-hand side of the equal sign is the command I'm interested in, and it is called mesh grid. Mesh grid. This command has two inputs to it, and they are both vectors. The first vector in the input here is going to be my list of x values, and the second input is going to be my list of y values. Now, in MATLAB, when I say list, what that really means is vector. So I'm going to create a vector of x values. In the slides, when I was doing this by hand, I let x go from -3 to 3 with a step size of 1. And so I'm going to do that here as well. A shortcut for doing that in MATLAB is -3:1:3. Now we remember from basic MATLAB syntax that that is a vector that consists of the numbers -3, -2, -1, 0, 1, 2, 3. I'd like the y's to be the exact same things. I'm going to put a semicolon at the end of this to suppress the output, and that's my command. Now, what's important to remember about mesh grid is that not so much the inputs, those are fairly easy to remember, but the outputs. For our purposes, we really have to have this kind of syntax on the left-hand side of the equal sign. A square bracket, x comma y, close square bracket, or use whatever variables you are interested in, be they uv or st or whatever. Now, what are these x and y anyway? Well, x and y are just matrices, as you can see here, and what they appear to be doing is just repeating the x values in each row and repeating the y values in each row. Individually, they're not so useful. Together, as a collection of matrices, what I can do with them is apply a function to them. So, for example, if I wanted to get the outputs for my function x squared plus y squared, x is right here, y is right here, and I can define z equal to x squared plus y squared. And I'm going to hit enter. And what you see here is a 7x7 grid that consists of all those z values, all those height values that we were going to plot earlier. Now, one thing to notice here is that in z, I do need to have the dot carets instead of just a regular caret to square the x and the y, because x and y are matrices or arrays and not just plain old numbers. Okay, so now I have three things. If you look over at my workspace, I have x, y, and z. The x is sort of like a list of x values, the y is a list of y values, and the z are the outputs. So now I can plot the mesh that I want. To do that, I use the command mesh, M-E-S-H. And this has three inputs, the x variable, the y variable, and the z variable. Except we don't need a comma at the end. Mesh is to two variable functions what the command plot is for one variable functions. It's going to create a plot of this mesh of dots that I will want to eventually tweak to make it look like my surface. So let's hit enter and see what we got. So there's our mesh. It may not look all that great, but remember we only have 49 points plotted, and what you get as a default here are the points plotted, also the lines connected, and it also puts in some little faces in between the lines here, so it looks sort of like a polyhedron. If I don't like how blocky this looks, what I can do is go back and redefine x and y. Say I want x not to go from -3 to 3 by step size of 1, or y either, but maybe I want a lot of points, so I might let x equal linspace -3 to 3, which will create 100 points between -3 and 3. Y the same way, not line space but linspace. Let's regenerate that mesh grid. Again, apply the function. Since I've changed my x and y, I now have to redefine z to use the updated x and y values. So there's my new z. It's so big it doesn't fit in the screen. Now let's replot that mesh again. X, y, z are my points. And somewhere back here is my mesh. There it is. Yeah, so now it looks much more like a surface, which is what we have come to expect x plus squared plus y squared to actually look like. The holes here, there are still some holes between the points, but it's much more like a very tightly woven fabric than, say, a hammock where the holes are really big. So let's try another example. Let's do z equals just x squared. And that should give us a parabolic cylinder rather than a paraboloid like we just saw with x squared plus y squared. So first of all, again, we have to define our grid of inputs using the mesh grid command. I'm going to define x to be -3, 0.13. So this is going to create x's between -3 and 3, but step size of only 0.1. And I'm going to define y to be -2, 0.12, so different range of y values. And then I'm going to create the grid of points by letting x, y in brackets equal mesh grid of x, y. And I know we're using x and y on both sides of the equal sign, but that doesn't really matter for our purposes here. And again, this is going to create a couple of matrices that hold all these point values you see. And now let's apply the function z equals x squared. There's that. That's, again, a lot of points, so I don't want to necessarily display them all. And then finally, let's get our graph here by typing mesh x, y, z. And again, there's our parabolic cylinder that we like. So to recap, to create a plot of a function of two variables in MATLAB, we use the mesh grid command to create the grid of input values, apply the function to create the output values for z, and then use the mesh command to generate the plot. Stick around for part 2 of this screencast where we'll learn how to change the plot up and change the color and do other neat things like that.